Okay, so on that, you end up with the f prime of x is 6x, and the derivative at x equals -1 is -6. Okay, now that's doing it all algebraically. Luckily, you have the calculator, so now we're going to look at the numerical derivative on the calculator. This book is written for all calculators, not just Texas Instruments. But on your calculator, there is a function, a library function built in that's called the numerical derivative. Okay, it's NDRIV. And if you look under the math key on your calculator, go to the home screen, second function quit, takes you to the home screen, and look under the math key, okay, and go down to math 8, okay, and probably put a little, if it's a key, I'd circle it, math 8 will get you to the numerical derivative, okay, and if we have it already in y sub 1, okay, I can just put in y sub 1, and then you have to put in a variable, okay, and the variable we're using is x, okay, and then you have to put in, we want the numerical derivative at x equals -1, and there's actually one more number there, but we're going to use the default, so we're not going to put that in. Okay, so on the home screen, do the the numerical derivative, and you can use the vars key, right arrow over to y variables function, okay, put in y sub 1. Yep. Yeah, I'll show you in a minute. Okay. And this one, you want to do y sub 1, okay, and then comma. Remember, that's on a key by itself. Okay, and then x, okay, and then comma, and then -1, and then press enter. Okay, and when you press enter, okay, so do you see that we got the answer in one step? Okay. Can I see? On the new ones, usually it's going to show up. Normally, the derivative, we say f prime of x. Another way to write f prime of x is the derivative of y with respect to x. So I'm thinking this is probably a y, this is probably an x at a specific number. I don't know. See if you can put, and then see if you can put in negative. I'm not sure. And then we need to get it so you can get, you guys that are doing that, do okay. If you have the new operating system, this is actually y sub 1 here. So you need to put in an x, the xt theta n key here. Okay, and then use your vars key, right arrow over to y variables function, pick up y sub 1, and it's at x equals -1. And then if you press enter, yours is actually press enter, and then it's going to show a -6. Okay, so especially those of you that have, and I would go ahead and write that down, because some of you may sell your old calculators and buy a new one, and that's what it's going to look like. Okay. What's that? Yes, yes. As long as you have the TID3 Plus and above, you can download, because that's got the flash technology. Yep. Okay. Okay. So, isn't that nice? That now you can find the numerical derivative, okay, on the calculator a lot quicker. Okay. The original method, okay, up here is what I call the long method. Do you have to know this method? Yes. Okay, and part of that is because just about every calc class, they're going to have you do the long method, and part of it so you understand what the derivative is and what the tangent line is. But now you can do the numerical derivative. Okay, the problem exists is that your calculator is going to give you a derivative, it's going to give you an answer, and the answer is going to be wrong at certain points. Okay, so when does the derivative not exist? Okay, so we need to go through that. Okay, Look at a graph as an example of, let's look at the graph of, in y sub 1, clear out your equations and put in the absolute value graph, absolute value of x. Okay, so clear out all the equations, put in, and it's under the math key, right arrow over to number, absolute value of x. And just do zoom 6. And I would probably straighten it up a little bit more than that. Do zoom 5, zoom square, and you should end up with a graph. Looks kind of like a V shape, like this. That's the absolute value graph. Now, if I said, what's the derivative at 0? Okay, on your calculator, go to the home screen. Okay, do math 8. Let's do the numerical derivative. And that's how you read that, the numerical derivative. We already put the equation in y sub 1. If you don't have it in y sub 1, I could type in absolute value of x. Okay, then you need the variable. Okay, and then I want you to figure the numerical derivative at 0. So do math 8, the vars key, y sub 1 comma x comma 0. Okay, and your calculator gives you an answer. Okay, your calculator gives you an answer that's wrong. Okay, the reason it's wrong is there is no derivative at x equals 0. The reason there's no derivative at x equals 0, if I took the slope of this part of the graph, okay, slope of this part of the graph would actually be -1. Slope of this part of the graph, if I say, okay, go in and find the slope of this part of the graph, would be 1. And what we learned from the other chapter was the derivatives, the slope of the tangent lines have to be the same coming in from the left hand endpoint and the right hand endpoint. As x approaches 0, it's got to be the same slope. It's not the same. Okay? So at x equals 0, no derivative exists. But your calculator gives you an answer. So you have to be smarter than the calculator. Just because you type it in and it gives you an answer doesn't mean it's correct. Okay? This is one of the points where a derivative does not exist, and that is at a sharp corner. Okay? So somewhere on this page you need to be putting a big caution. Okay? Yep. Sometimes the calculator figures a derivative when no derivative exists. Okay? And you have to know when it's giving you an error. Okay? One way to look at the derivative graph, okay, in y sub 1 we had the absolute value of x. If I graph that, okay, I get that V graph. Now I want to actually look at the derivative graph. To get the derivative graph in y sub 2, you put in the numerical derivative of y sub 1 comma x, and we want to look at the graph, so it's not at a specific point, it's just at x. Okay, and let's turn this one on. Okay, turn this one on, turn the other one off. Okay, so go down to y sub 2, do math 8. Okay, then the vars, right arrow over to y variables, function, we need y sub 1 comma x comma x. And that's the standard for looking at the derivative graph. Okay, turn off the y sub 1. Remember, you get your cursor on the equal sign on y sub 1 and press enter. That should make it light, and the other one, y sub 2, should be dark. And now graph that. Okay. Now, you also have to be real careful on these that there's part of that graph you're not seeing. Okay, so you have to turn the axis off. So right above zoom, do second function format. And I could have found that if I had put the trace key on. Okay, turn the axis off. And one more thing, it looks like it's connected. Okay, one more thing, go into mode and go to dot mode. There we go. Okay, and that's the derivative graph. Okay, the derivative graph. You see part of it down here. Part of it is right at the origin, and then part of it's here. Okay, and when we got the error, we got actually that derivative is 0, but no derivative exists at x equals 0. Okay. Okay. Now we did a couple of things there. We did dot mode. So on some of these, you may have to go into dot mode. We also did zoom, second function zoom, second function format, and we turned the axis off. Okay. There will be times where the graph is graphing right along the x-axis, so you may need to turn it off. Okay. Okay. So basically, I've shown you one. Okay. I've shown you one place where the derivatives don't exist. Okay, and that's at a sharp corner. Here we go. Okay, so we're going to go through all the places where a function does not have a derivative. Okay, and I've shown you one at a corner. Okay, so when does a function not have a derivative? And the first one we just talked about, at a corner where one-sided derivatives differ. And that was like the absolute value. The left-hand derivative slope was -1, the right hand slope was 1. They were not the same. So it might be a graph that looks like this. Okay, I'll tell you, today's the day. There we go. Okay. Okay, so there's no derivative at a corner, and it might be straight lines, like our absolute values. It might also be one where you have a line coming in here and a curve coming in here, but they're not the same. This derivative does not equal the same slope as this derivative. Okay, if that's a straight line and a curve. Okay, so there's no derivative at that point. Okay. Another way to say that is slopes of the tangent lines. Okay, slopes of the tangent lines from left and right are different. Okay, so that's one time that the derivative does not exist. But the calculator may still figure an answer. Okay. Second place, okay, is at a discontinuity that makes the one-sided derivatives infinite. An example would be like if I said figure the derivative of this hyperbola, okay, and say I have a hyperbola like this, and if I said what's the derivative at x equals 0, okay, no derivative exists because it's a point of discontinuity, okay, so your left hand and right hand can't be the same, okay, so it's at a point of discontinuity where the derivatives would be infinite, okay. And the third one is at a vertical tangent, okay, at a vertical tangent. And with your iPads, you can look up, you know, just on the different types of where do numerical derivatives not exist, and you'll get a lot of information, a lot of more examples. Here would be a picture of one. Say I have a graph that looks like this. Okay, and if I did the tangent line there, my tangent line would look like this. Okay, at a vertical tangent. Okay, and what's the slope of a vertical line? Undefined. Okay, vertical line has no slope. Okay, so that would be another. Okay, let's look at an example. Say they give you the numerical derivative of, and let's look at the cube root of x, that, and the variable x, and let's find it at 0. Okay, let's do it in the immediate mode first, in the home screen. Okay, so do math 8. Okay, and the cube root. Remember, you can find the cube root under the math key, and it's number 4. The cube root of x, close the parentheses, and then comma x, comma 0. Okay? Okay? And then go ahead and press enter. My calculator gives 100. Anybody have anything different than 100? Okay. So the calculator gives you a derivative. Okay. Now let's look at the graph. Okay. Clear out. The only one you need to clear out is y sub 1. Okay. So in y sub 1, you're going to put in the cube root of x. In y sub 2, you're going to leave in that, and I would probably leave that in for most of this section because it's going to be the numerical derivative of y sub 1 comma x comma x. Okay. So put in the cube root of x. Now turn off the second one for a minute and just look at the graph. You got to get your cursor on the equal sign. Get your cursor on the equal sign there and turn that second one off for a minute. I just want to look at the cube root graph. Cube root of x. And I turned off the axis already, but you'll end up with a graph that looks like this. Okay, for the cube root graph. Okay. If you figured the derivative at x equals 0, it's going to be a vertical tangent. Okay, no derivative exists at x equals 0, so this is an error. Okay, the derivative is not 100. You would just say the derivative does not exist at x equals 0. Okay, well let's show it. Turn off the y sub 1. Get your cursor on the equal sign. Okay, and then turn on the y sub 2. Okay, this is the original graph. Now let's look at the derivative graph. Okay. Okay, and let's zoom in a little bit more. Zoom in, zoom, let's do zoom 4. See if it shows a better picture. It should, when you look at that graph, should look something like this. Dot looks better. Yeah, there it goes. It's starting to show straight up. Okay. So you may have to be in dot mode to see this. So if you look at this graph, does that derivative exist at x equals 0? No. Okay. Okay. So on this one, no derivative exists at x equals 0. And that's where you got to be careful. The calculator gives you an answer. You've got to be smarter than the calculator. Okay? Okay, a couple more things to finish off this section. Okay? Okay, one thing the author goes through in this section is what they call the intermediate value property. Okay, the intermediate value property. Okay, and it says if your function f has a derivative if f has a derivative at every point of a closed interval, and remember, for a closed interval they're using the brackets. Okay, if it has a derivative at every point of a closed interval AB, then f prime assumes every value between f prime of A and f prime of B. That means there would be a derivative for every, there would be a value for everything in between A and B. Okay. Last example. Say I give you the polynomial y equals x cubed minus 4x minus 5. I want you to graph that in the window. Graph negative 5 to 5 for your x min, x max, and scale 1. For your y, let's go negative 20 to 20 and scale 4. Okay. Clear out just the first equation, the y sub 1. Put in x cubed minus 4x minus 5. Okay, turn off y sub 2 so you can look just, and you should already know what a cubic graph is going to look like. Okay, and I'm not seeing the whole graph. I need the window. Change the window to negative 5, 5, scale 1, and negative 20, 20, scale 4. Let's go ahead and turn the axis back on. It's under right above zoom, second function format. Turn the axis back on. Okay, so now they will ask you in this, are you seeing a complete graph? Are you seeing all the max and min points? Max and mins, are you seeing all the x and y intercepts of a cubic graph? Yes. Okay, that is a complete graph. Okay, now, that's a cubic graph. Okay, now, I want you to turn this one off and go into y sub 2. Okay, go into y sub 2 and turn that one on. Look at the numerical derivative. Look at the derivative graph of y sub 1 comma x comma x. You may have to, we'll see if we have to adjust the window. Turn this one off. Get your cursor on the equal sign on y sub 2. Turn that on. Graph that. And you can see I'm still in dot mode on my calculator, but you end up with a graph. Looks something like this. That's just kind of a rough sketch. Are we seeing the whole graph? Yeah. Okay. What power would this graph be? Y to the y equals x to the. Yeah, this is a y equals x squared. Okay. If I had you do an x to the fourth graph, you would end up with a cubic derivative. Okay. If I have you take the derivative of this graph, what would it be? It would be a line. It would be an x to the first. Okay, so that brings up their last point. Given a polynomial of degree n, and the example I gave you was a cubic graph. It was to the third power. The numerical derivative of f of x, the numerical derivative of f of x is a polynomial function of degree n minus 1. Your derivative is always, the degree is always 1 less than the original. Okay? So if the degree is n, the derivative. So if this one was an x cubed, the derivative, and this would actually be the y prime. Okay? Okay?